Math 3, Unit 3, Section 6. Today we're going to talk about factoring by division using long division and synthetic division. Now, way back in elementary school, you guys were taught how to do long division, correct? No, not everyone, some of you. Okay, so we are going to do, if you notice right here, do you see how we have two of the same exact problems? So we're going to solve it one way using long division, and then we're going to also solve the same problem using synthetic division. Synthetic division is a shortcut. It makes life a lot easier. Long division is a little bit more complex, but both ways will get you the same answer. Okay, so to start off with, in order to teach you guys this, in the middle here, I want you to write 5 divides into 370. Do not solve that, okay? So this is going to help us with our process of learning long division when we're dealing with polynomials. Okay, so how I always remember, and I don't know how you guys remember with long division, but I know that the first one always gets to go inside. I think about if I'm like walking up to a door. Normally the first person at the door goes inside first, unless you are a kind person and hold the door for other people, which I hope you all are. But so this one goes inside the long division, okay? So x minus 1 is going to go outside, and then x squared plus 6x minus 7 goes on the inside. So far we're just setting up our long division. Everybody good here? All right, so the first step, and we're going to start by going over here, is that 5, we want to see, and see how it can't go into 3, correct? And so we go to the next number. So how many 5s are in 37? 7. Okay, so everybody just write a 7. Do not go any further. Okay. Now, what we're going to do over here is we look again like at our first number, just like how I was looking at 5 here. And we look here at the first number. Now, x times what would make x squared? X, right? Does everybody agree? It's the same idea how we're going like 5 times what would make 37 or something close to 37. In this case, we're doing x times what would make x squared, and the answer is x. Now, just how we lined this one up here, because that's what it was going into, over here, x, we're going to line it up with our x term. If I had needed x squared, I would line it up with my x squared term. But by lining it up with your like terms, it's basically telling you you're going to have a number or letter here and a number or letter here, and then you're done. Just like on here, I'm only going to have one more letter and then or number, and then I'll be done. Am I making sense there? So you line it up with the like term. Now going back to this problem, what is your next step that you do with long division? Good, you multiply. You multiply 7 times 5. And again, do not go ahead and do not be on your phones right now. 7 times 5 is what? 35. 35. Okay? We're going to do the same thing over here. Okay? So over here, we have 2 terms though. We have to multiply the x times both of them. So x times x makes, good, and x times negative 1 makes negative 1x. Okay, questions? Okay, going back over here, what do you do next? You always subtract, okay? And so 37 minus 35 is what? 2. Okay? Is everybody good there? Okay, so over here, guess what we have to do as well? Subtract, but we have 2 terms. And so when you're subtracting over here, these always change signs, both of them, because when you're subtracting, each of them change signs. And so this will be a minus and this will be a positive. Okay, so let me try this one more time. So do we all agree that we subtracted here? Okay, so we're going to subtract over here too, but we have 2 terms. We have to subtract both of them. So this one was a positive, so it becomes a negative. And when you're subtracting here, this was a negative, so it becomes a positive. So when you're subtracting, whatever the signs are, they always become the opposite. Okay? And so here, and the whole purpose is that these would cancel out, which they do. And then you combine your like terms here. So what is 6 plus 1? 7x. Okay. So we're going to stop there. We're at the same place on both of these. Okay? Going back to this one, what do you do next?
Bring down the 0.
You bring down this 0. Okay? So guess what I'm going to do over here? We're going to bring down the minus 7. Okay? What's next? What do I do here? Good, because we go 5 times what equals 20, right? And 5 times 4 is 20. Yes? Okay, so we're going to go over here. Same thing, okay? We're going to go x times what makes 7x? 7, right? And it's specifically a positive 7. Okay? What? Wait, what?
Why aren't you using the minus 1 and x minus 1?
Okay, I'm not sure I'm completely understanding your question. I'm going to try to explain what I think it is. Just like over here, I was figuring out 5 times what makes 20? 5 times 4 makes 20. Over here, my number right now is 7x. And so x times what makes 7x? And
But like the x minus 1. Or are you ignoring the x? I mean the minus 1.
I'm not ignoring it. We're using the minus 1 when I'm distributing it through. And so when we're doing long division, we are only looking at this first piece, okay? And the other piece, we are using it when I'm multiplying out, okay? So you only have to worry about the first term here and the first term here, okay? So it ends up working out when we multiply it through. It's just when you're doing long division, you're only looking at your first terms, okay? So we decided that x times 7 made 7x, correct? Okay, and so just like over here, we're going to go 5 times 4, which is 20, and then we subtract, okay, and there's 0 left over. We're going to do the same thing over here now. 7 times x is 7x, and 7 times negative 1 is negative 7, okay? And then we have to do what? Change your signs because we're doing what? We're subtracting, right? So when we subtract, each of these signs change. That becomes a minus, this becomes a plus, okay? And what ends up happening? They all cancel out and we have a remainder of 0, just like we have a remainder of 0 right here. And so it says, is x minus 1, okay, so x minus 1 is what we're dealing with right there. Is x minus 1 a factor of this problem? And my answer is what? Yes. Okay, yes, it is a factor. And the reason why the answer is yes is that there is a remainder of 0. If I had a leftover number here when I subtracted, if there was a remainder, then x minus 1 isn't a factor. It has to divide evenly into it in order for it to be a factor. Now, we're still going to do synthetic division, but I think we want to practice with long division one more time, just so you guys can see the process. So we're going to go down to this next one with long division.
Is there a shortcut?
Yes, I actually said that at the beginning, that synthetic division is actually a shortcut, but I want you to understand this first, and then we'll use the shortcut, okay? All right, so let's write this one out, and if you notice, we're only doing 2 problems long division, okay? The reason why I want to teach you long division is that it is a specific standard that's stated that says that I'm supposed to teach it to you. So I'm teaching it to you, and then I'm showing you the shortcut. Okay. All right, so we have x minus 2, and then we're going to go inside here, and we have x to the third plus 5x squared minus 21x minus 9. Okay, so if we look at this, x and x to the third, x times what makes x to the third? x squared is correct. So I'm going to line that up over my x squared term. Okay, who remembers what my next step is? Very good, multiply. And so we go x squared times x, which is, good, x cubed. And x squared times negative 2 is negative 2x squared. Very good. What do I do now? We change our signs because we are subtracting. So this becomes a minus and this becomes a plus. These cancel. 5 plus 2 makes, good, 7x squared. What is next? Very good. We bring down our next term, which is negative 21x. Okay? Again, we are always looking at just our first terms. Okay? And so x times what will make 7x squared? Good. And specifically, that is a positive 7x. So we put plus 7x. And what do I do next? Multiply. So 7x times x is 7x squared. And 7x times negative 2 is, good, negative 14x. And what do I do now? Change our signs. So this becomes a minus, and this one becomes a plus. 7x squareds cancel, and what am I left with? Negative 7x, and then we bring down the minus 9. So negative 21 and positive 14 make a negative 7x, and then we bring down our last term there, which is negative 9. Okay, so again, we are looking at our first terms. Okay, x times what makes negative 7x? Negative 7, good. So negative 7, and then we go negative 7 times x is negative 7x, and negative 7 times negative 2 is positive 14. Okay, next I what? Change our sign. So this becomes a plus, and this one becomes a minus. These cancel, and what am I left with? Negative 23. Okay, so how you would write this when you have a remainder of negative 23 is you go plus negative 23 over, and I've been dividing by what? X minus 2. So whatever your remainder is, you put that over what you're dividing by. So would we say that x minus 2 is a factor? No. And why not? Good. So no, and that's because there was a remainder. Okay, so now let's talk about the shortcut. Okay, so if you notice, we're going to be doing the same problem up here using what's called synthetic division. Okay, so when you're using synthetic division, the number that you're dividing by, remember how when we have something in parentheses, we set this equal to 0? So this, the x-intercept or the factor, when you set this equal to 0, what value is that actually?
1.
It's a 1. Okay, and so we're going to be just dealing with numbers and not letters right now. And so we're going to put 1 here in a little box here to the side. The next thing you're going to do is whatever we're dividing by, and right here, is we are going to take the coefficient of each of these numbers. Now you want to make sure it's in descending order. If it wasn't in descending order, like you know how this goes second power, first power, and then there's no power here, you would add in like a 0. If it was missing a plain x term, then you'd add in a 0 for that plain x term. Okay? We'll deal with it when we get to it if we have one. Okay, so what's the coefficient on x squared? 1. What is the coefficient on 6x? 6. And then we have negative 7 here at the end. Okay, so is everybody clear on where we got these numbers? Okay, so we need to leave space because we're going to have to write some other numbers here, but we're going to draw a line, okay? And so make sure you have space to write some numbers in here in just a minute. To start the problem, you always bring down this first number. Okay, so we're going to bring that down, and so we write that below our line, and we have a 1. Okay, the next thing we do is we multiply these numbers. 1 times 1 is what? 1, and 1 goes here. And then we combine these terms. 6 plus 1 makes 7. Okay? Then we multiply again. 7 times 1 is 7. We write that here. We combine these terms, and we're left with 0. This number at the end is my remainder. Okay? Which is 0. Which we agree over here was 0, correct? Okay. And so what's left here, you always go down by 1 exponent from what you started with. Okay? And so that means my answer for this, if we go down by 1 exponent, instead of writing 1x squared, we would write 1x or just x. And then if you go down by 1 exponent, there is no x, and you just have plus 7. So this answer becomes x plus 7. Denise, question. Go over how I go. So let's try to put some notes on here for you guys. I think that's what you're asking me to do. Okay, so first thing is that this number right here goes in here, and it's always going to be the opposite. Okay, these numbers right here, those are the coefficients of each term in descending order. Okay, here, bring down the first number. Okay, and then I'm not sure how, so and then you multiply each number. Would that make sense? Multiply each number and write it in the middle. Multiply each number with the boxed number and combine terms. I don't know, hopefully you guys will be okay. Okay, is that better? Is that kind of what you're asking for?
Where's your opposite? Where is supposed to be the opposite?
Good, where is the opposite? Anybody know where the opposite is? At the very beginning, you have your opposite right here.
Opposite of what though? 'Cause the
Opposite of x minus 1. So if you set x minus 1 equal to 0, since it's negative 1 here, the opposite is positive 1. If you would rather write set x minus 1 equal to 0, and that number goes in there, that's what you're doing.
Is that what that little one in the thing is supposed to be?
I'm not quite clear on what you're meaning.
Wait, right here. Is that what that's supposed to be?
Uh-huh.
Oh, okay.
Okay, so is it a factor x minus 1? Our answer was yes. And again, the reason why it's yes is that it has a remainder of 0. Okay, are you guys ready to try another synthetic division problem? I think that I'm going to have to move on, but you can copy it after, okay? All right, so the first thing we're going to do is this number right here, we set it equal to 0, take the opposite. So what's going to go in my little box? -2. Next step is we write the coefficient of each of these terms. Does this go in descending order? No, it does go in descending order, but it's missing something. Do you guys see what it's missing? It's missing an x squared. And so what I might suggest you write is write it out with a 0 in there. So we have x to the 4th plus 3x to the 3rd. I'm going to put plus 0x squared plus 6x minus 2. So that's what I mean by adding a 0 in if it's missing one of the exponents. Okay? So now when we write the coefficients down, what will be my coefficients? 1, 3, 0, 6, and -2. It is important that you have that 0 in. Okay? Now, we draw our line, and what's the first thing I should do? Bring down our first number, which is 1. That starts us off. Okay? And then we just multiply and write it in and add down. Okay? So, what is 1 times -2? -2, and 3 minus 2 is 1. Okay? Again, we multiply. 1 times -2 is -2, and 0 minus 2 is -2. Multiply again. -2 times -2 is +4. We add down and get 10. 10 times -2 is -20, and we add down and we get -22. And that number is always our remainder. So was this one a factor? No. And why not? Good. Or, yeah, the remainder wasn't 0, or there was a remainder. However you want to write that, it both means the same thing. Okay, so we need to write this answer, though, because they still wanted us to divide and find the answer. And so we always start, this is my coefficient of my first term, but we go 1 less than this. So it's not going to be x to the 4th. My answer is going to be x to the 3rd. So it's 1x to the 3rd. Plus, because it's a positive number, right? X squared, and you could put a 1 there if you want to, 1x squared, and then it's going to be minus 2x, and then it's going to be plus 10. And do you remember how I said you write the remainder? So, perfect. So it's plus, and then you have -22, which was our remainder, and we divide it by whatever we're dividing by, and we're actually dividing by x plus 2. Yes, Destiny?
Do you know how to go like less than 1 exponent?
Uh-huh.
Why wouldn't like the 6x, why wouldn't this be 6?
Okay, so remember how we are missing the x squared. When you're dividing and you're multiplying, there's going to be a point when we get an x squared. Okay, and so this is how it would work. And I could show you through long division what actually happens, that whole long process. We could do that later. But you're just taking your original exponent and you're going down by 1, and then each of these terms goes down by 1. Because this is like your, you know, like your different columns where we have the like terms. Okay, all right, yes.
What equation do you use? The one that you put the 0 in, or to get the answer?
What equation do you, for long division, what equation would I use?
No. You know how you got like the x to the 3rd plus x squared?
This?
Yeah. You use the top, the one that the 0 put.
Yeah, yeah. But you're always going to start with your highest exponent. You wouldn't put like a 0x to the 5th. You wouldn't go in front of it. So it's just always whatever your highest exponent was, because you want them in descending order. And so yeah, but I would always rewrite it anytime you have a 0. But so you're starting x to the 4th, and we go 1 less than our highest exponent, which is x to the 3rd. Okay, any other questions? Okay, so here they're saying factor completely. And so we are going to use synthetic division in order to divide. Okay? And then we're going to see if we can divide further. So, Cameron, please put it away. What's going to be the number in my box? Very good. Positive 5. Okay, is this in descending order? Yes. Do I need to add in any zeros? No. So we're going to write it out. What will be my numbers? 1. Perfect. Draw our line. What do I do first? Bring down the first number, which is 1. 1 times 5 is 5, and then we add those together and it makes 4. 4 times 5 is 20. We add those down and we get 3. 3 times 5 is 15. We add those down and we get 0. Okay, so, and they're telling you that these are factors, and so we know this is a factor. So right now, let's go ahead and rewrite this. How would I rewrite that? X squared plus 4x plus 3, and that's in parentheses. And when this was a factor, x minus 5. So if we were to multiply this all out, we would get back to this original problem, correct? Okay, and then they want us to factor further. Can this be factored further? How do we check? It's 3 terms. How do we factor trinomials? Okay, my multiplication number is 3. My adding number is 4. What numbers multiply to be 3 and add to be 4? Good. Positive 1 and positive 3. Okay, so I still have x minus 5. We make our 2 parentheses. We're using our shortcut. What goes in the front of both parentheses? X. And what goes at the end of both of them? Plus 1, plus 3. And again, remember, these 2 numbers should multiply to be the last number. 1 times 3 makes 3. These 2 numbers should add to be your middle term. 1 plus 3 makes 4. So this is now completely factored. And we're done. Okay. Should we try another one? You think we're okay? Can we move on to graphing?
No.
Okay, so we're going to turn the page. Okay, so this one is also set up a little differently. Do you see here, it says given 1, 0. So they're telling you this is a 0. So what they're saying is that on the graph, there is a 0 at 3. If I were putting it on the graph there, there's a 0 at 3. Okay? In parentheses, what does that look like? As a factor, what does that look like? X minus 3. Do you guys agree with that? That if they're telling you that a 0 is 3, that as a factor, that's really x minus 3, because when we set it equal to 0, it would equal a positive 3. Okay? Now, we are going to use, since they're telling us that 3 is a 0, which means it is a factor of this problem, we can use synthetic division in order to get to see how it goes down. So, what's going to go in my little box for this one? The number 3. Very good. So if they tell you something is 3, okay, it's a 0, that's the number that goes in the box. But we know it came from x minus 3. Yes?
So
You wouldn't change it because they already changed it. Does that make sense? Yeah, so if it's not in the parentheses with the x like that, then you know it's already been taken care of. Okay, they've already solved and told you what value to put there. Okay, Is this one in descending order? Yes. Is there any place I need to add a 0 in? No. Okay, so let's write these numbers out. So what are my numbers going to be? 2. Perfect. Draw a line. What's my first step? Bring down the 2. 2 times 3 makes 6. We add down and I get 11. 11 times 3 is 33. We add down and I get 5. 5 times 3 is 15. We add down and we get 0. Okay? So that means that this, how do I write that answer? Okay? And if we're writing this all out, there is an x minus 3 there in front. Okay? Now, can I factor that further to find my x-intercepts? Good. So how do I find my x-intercepts at this point? Good. We always multiply over. Okay, this time we multiply over there and we get 2 times 5, which is 10. Can I use my shortcut on this one? No. Anytime we have a coefficient in front, we can't use the shortcut. Okay, have to factor by grouping. What's my adding number? Okay, what numbers multiply to be 10, add to be 11? Okay, so we can't use the shortcut. That means that 11x breaks down to 10x and 1x. And then we still have our plus 5, and we still have our 2x squared. Factoring by grouping, we group this together. What's my GCF? 2x, and I'm left with? Good, x plus 5. What's my GCF at the second group? Just 1, good. And so we're left with x plus 5. So what does that end up becoming? Okay, 2x plus 1 and x plus 5, and then I still have my x minus 3. Okay, and so this is my fully factored equation. Okay, and so now what do we do in order to graph this? Good. First of all, my degree is what? 3. My leading coefficient is what? 2. Okay. What do I have to do now? Find your x's. Setting each of these equal to 0. This one is going to be x equals 3. And is that going to be a bounce or a passing through? Yes.
3 from the original one that you used?
Mm-hmm.
Like the very first one without change? Like the 2x cubed plus 5x, that one?
Ask your question again.
Where'd you get the degree from?
This 3, they just gave it to you. They told you that 3 is a factor, so we knew that we could divide 3 and the x minus 3 into this problem. What?
Oh, she's talking about the degree.
Oh, the degree is from right here, the original problem. The highest exponent's 3.
Oh, you can just count the numbers in the factor.
You can. What does it equal? 3. Either way. Okay, when I set this one equal to 0, what does x equal? Close? Negative 1/2. Is it bouncing or passing? Pass. Nia, are you getting all this? Somebody give her a little nudge, please. Okay. X plus 5, what does it equal? X equals negative 5. Is it bouncing or passing? Passing. Okay, so negative 1/2. Here, just focus back up here. Here we go. That's a pass. 3, we have a pass. And then negative 5 is a pass. Okay. So, my right in behavior, which way is it going to go? Positive infinity, why? Leading coefficient is positive. My left in behavior is going to go which direction? Negative infinity, why? Odd degree, it goes in opposite directions, good. As I start going through here and this passes and I go through here and this passes, what do you notice? We need our y-intercept. How do I find my y-intercept? Plug in 0 for x. Now, you can plug in 0 for x here and solve, but what is way easier? The original equation. If we go back here to the original equation, right here, anything that has an x becomes a 0, correct? And so what would my y-intercept be? Negative 15. It's the value without an x. If it's in standard form, that is your y-intercept. So in this case, my y-intercept is at 0, negative 15. And so we are just going to make a mark on here. We're going to call it negative 15. So this is going to pass through, hit the negative 15, turn around, and then it passes through again, and we're done. Okay, and so we're not going to do this whole last example for h, but I just kind of want to start you on it really quick. What value would go in my box right here? It's going to be negative 5, because when they are saying this is a factor, that means that's negative 5 we'd mark on the graph. This actually means x plus 5. Okay, do I have to add any zeros in here? No. So what are my values? 1, 9, perfect. Okay, we bring them down, right? The next step is to bring it down. 1. What's 1 times negative 5? We add down, we get positive 4. 4 times negative 5 is negative 20, and then we get, and then 4 times negative 5 is, and how much is left over? 0. How do I write this out now? X squared. Okay, and then I still have what here? What's the parenthesis in front? X plus 5. What factors? What multiplies to be 4? Adds to be 2. Adds to be 4. 2 and 2. Good. So that means we get x plus 5, x plus 2, x plus 2. But how would I rewrite that? Good. So y equals x plus 5 and x plus 2 squared. Okay, I'm going to go ahead and finish this, but I'm going to keep going a little faster. So next I'm going to do what? Set them equal to 0. Okay, we can do the degree. What's my degree? 3. What is my leading coefficient? 1. Should we go ahead and state what our y-intercept is if we look back at the original problem? What's my y-intercept going to be? Very good. When you plug in 0 for all the x's, you're left with 20. X plus 5, that's going to make what? Negative 5, bounce or pass? Yes, Denise? Yes, because when I plug in 0 for x, that'll make a 0, that'll make a 0, that'll make a 0, and then you'll be left with 20. Okay? This will make x equals negative 2, and is it a bounce or a pass?
Bounce.
Bounce. Okay, plot these points. Negative 5, 1, 2, 3, 4, 5. That is a pass. Negative 2, that is a bounce. 20 is my y-intercept, so I mark a 20, make a point there. Okay, and... Okay, right in behavior, where should it go? Up. Why is that? Good. Leading coefficient's positive. Left side should go down because it is it's an odd, so opposite. Passing through, hits here, bounces up, and it goes straight through. And we're done.